Hello and welcome to Math Plus Tutors. Today we're going to be working on trigonometric functions and equations. You know your trig ratios like sine x, cos x, tan x, and you know also your reciprocal trig ratios cosecant x, secant x, cotangent x. Now I am going to do a function that's in terms of a sine x. So if I say that my y equals sine x, can I graph that? So if we need to graph it, I need to know the values. So I am going to graph this on an interval 0 to 2 pi. In radians, 2 pi equals 360 in degrees. So I will be graphing that period. If I have my unit circle here, as you can see, I am starting from a 0. Then I go to pi over 2, then I go to pi and 3 pi over 2, and then we go back to 2 pi. That's a whole cycle. In this case, my x-axis, that's my y. Okay? If I have my sine x, then sine of 0 is a 0. Okay, so let's graph that on a graph here. That's my x, that's my y. What I will do, I will take my period and put it here. That's my 2 pi. Then it's very important to decide on your quarter of a period. So what is the quarter of 2 pi? That's pi over 2. So if we go here, that's a half. It will give me a pi. Halfway through, pi over 2. And then another halfway through, 3 pi over 2. At 0, y equals sine 0. Sine 0 is a 0. How about sine pi over 2 or 90? That's a 1. So this is my 1. How about sine pi? That's a 0 again. Sine 3 pi over 2, that's my negative 1. Let's make it a little bit better here. Oh, do it again. That's my negative 1. So negative 1 goes down here, and then I have another 0. If I am to graph this function, I will take this line, goes up, then comes down, and then goes up again. Is that the only function that I will have here, or the only wave? No, actually, if I were to continue here to say 4 pi, so I'm going to be graphing another period, I will have the same exact shape repeated. So I will go to the 1, go to 0, again negative 1, and 0 one more time, and that will be my function. Okay, general form for sine function is y equals a sine, say, 2x minus, say, pi over 3 plus 2. That's my function here, and then instead of a, I am going to put a number, so let's say a 5. How can I find information, important information from this equation? Well, this 5 here stands for my amplitude. So amplitude equals 5. How about my period? Well, for my period, I need to take this number, which is a horizontal stretch or compression factor, and divide 2 pi by it. So 2 pi over 2, that will give me just a pi. So in this case, for this equation, my period is a pi. If that's my period, how about my frequency? Well, frequency is just 1 over the period. If the period takes 2 seconds, then how many waves can happen in 1 second? That will be 1 over 2, or 1/2 of that. So the frequency will be 1 over p, or 1 over pi. Okay, the last part here will be the phase shift. So phase shift for my equation is this portion here. That's a pi over 3. Notice that we have a negative sign. So if I have a negative sign, that means this phase shift is to the right. If I happen to have a positive sign, that means my function is shifted to the left. Okay, how about this number here that we didn't talk about yet? That will be your vertical shift. Vertical shift means the line that's two units up, that's the line that splits your graph into two equal parts. Like in this case, my x-axis, as you can see on this graph. So if I am looking for graphing this function, I will do the same as I have done earlier. I will take my x and my y. And then I will look here at my information. So I have an amplitude of 5. I will take the 5 up. Let's move this a little bit up. 5 up here and corresponding 5 down here. So negative 5. And then I have my period is pi. So if I am going with a period of pi, so let's say this is pi now. So that will go to 2 pi, 3 pi. You get the idea. We can also go from the negative side, negative pi, negative 2 pi. Okay, now this is all what I need to do to decide on the period and the amplitude. How about the phase shift? The phase shift is pi over 3. So pi over 3 is 1/3 of this distance here. So let's say this is the pi over 3. And it's shifted to the right. This means my function starts from here. We know that sine starts from a 0. Then that will be your first 0 that you will encounter. Okay, the period finishes here. So, okay, so that will be where it finishes. And then I will have this period here to get the quarters. So just by visual clue here, that's the half, let's say. This is my half. This is my 1/4, 2/4, more or less. Okay, so it goes from 0 to the maximum. Maximum happens at the first quarter, and then 0, and then the 2nd quarter is a 0, 3rd quarter is a negative, so that's the minimum, and minimum here, and then I have my 0 goes back to 0 again, so my function goes like this. Here. What if I want to graph more than one period? Okay, I will repeat that. So it ends here after a 1/3. Okay. Okay, that's the half of it. Well, my cursor is really not being nice today. And we go halfway through, we go to the minimum, and then we go back. And there you go. You have it. If you want to continue, you can continue the graph from the other side as well. So that will end, say here. I have to go down to up and down again. Okay, what if I have an equation? My equation says sine x equals half. That will be for another time.